For position time graph, let's rub this velocity time heading for now. To understand position time graph, imagine a cart having wheels moving on this road. So, with a constant velocity. To measure position, we can put numbers 0, 1, 2, 3, 4, and so on. So, if you try to draw the graph y, x, and suppose it's this denotes time and this denotes displacement. Okay, so you can take symbol x as instead of x. So the graph, if it's if the you know the position of this card from t is equals to 0, you can draw the graph as so. This is a line which denotes constant velocity. Why I'm saying that in this case when v is constant the graph is looks this, because you don't know the equation of velocity. They, because if you move with constant velocity, suppose you are constant velocity which is 0 meter per second, means you are not moving your position. Suppose you are here from 0, so your position remains same with time. Okay, then the what is mean the slope of the line is 0, theta is 0, tan 0 is 0, so the slope of this line is 0. If slope of this line is 0, then if m is 0, then y is equal to c, means x remains c. What is c? C is an intercept, so it remains the value which uh, it remains at its position, initial position basically. But if theta is not 0, then m is not 0, therefore with time its position change. And if its time its position has changed, and every second position change with same magnitude, means constant velocity, say 10 meter per second. So 10 meter per second every second. So in equal interval of time, that is the definition of constant velocity, it travel equal displacement. If this time displacement is same and these time displacement is same. So this denotes the constant velocity. What happens if velocity is not constant, means the in case of accelerated motion. In case of accelerated motion, we can rub this line. You can take screenshot if you want. So in case of accelerated motion, means suppose positive acceleration, means velocity increases with time. So velocity increases with time means first it takes large time to travel small distances, but with time as its velocity increase, it takes less time to cover the same distance. So the graph is bent towards it take less and less time to travel larger and larger distances. And what happens when a is negative, that is when velocity decrease. When velocity decrease, it takes larger and larger time to travel same distances. So the curvature of line bends in this direction. So like this. So what is the conclusion? There you can encounter with two kind of motion when dealing with straight line motion. Whether the motion is constant, which could also be zero, or some constant value, then the velocity time graph is a straight line. And if the motion is accelerated, positive acceleration or negative acceleration, then the velocity time graph is a parabolic in nature. This is a curve uh, which has a name called parabolic curve. So, parabolic nature. Till banded towards displacement axis means positive, banded towards time axis means negative. So this is how the acceleration and uh, acceleration zero and accelerated motion is described graphically. One thing which can add is, but I can't, the case of relative motion. So since we don't study relative motion, so I uh, put this at hold, and let's tell you what is a relative motion, but not in this section, in next section. Let's close it for now, and let's meet you in the next section of this series.